Overview of a split AC system. A split air conditioner, AC, consists of two main separate units, one installed inside the room and the other placed outside. The two units are connected by insulated copper tubing and electrical wiring, allowing refrigerant to cycle between them to remove heat from the indoor air and release it outdoors. Major components. 1. Indoor unit, evaporator. Installed on the wall inside the room, this unit is responsible for delivering cooled air into the living space. Evaporator coil. Cold liquid refrigerant flows through this coil, absorbing heat from the room's air. Air filter. Catches dust and debris to keep the coil clean and maintain airflow. Blower fan. Draws warm room air across the cold evaporator coil and circulates the cooled air back into the room. 2. Outdoor unit, condenser. Placed outside the building to discharge the absorbed indoor heat into the atmosphere. Compressor, the heart of the system. It pumps and compresses the refrigerant, increasing its temperature and pressure to keep the refrigeration cycle moving. Condenser coil. Receives hot, high-pressure gas from the compressor and releases the heat into the outside air, changing the refrigerant back into a liquid state. Axial fan. Blows outdoor air across the condenser coil to accelerate heat rejection. How the refrigeration cycle works. The split AC relies on a continuous closed-loop cycle of evaporation, compression, condensation, and expansion. Heat absorption. The indoor blower fan passes warm room air over the cold evaporator coil. The refrigerant inside absorbs the heat and evaporates into a low-pressure gas. Compression. This gas travels through copper piping to the outdoor unit's compressor, which squeezes the gas, raising both its pressure and temperature significantly. Heat rejection. The hot gas enters the outdoor condenser coil. The outdoor fan blows ambient air across the coil, causing the refrigerant to shed its heat and condense back into a high-pressure liquid. Expansion. The liquid refrigerant passes through an expansion valve or capillary tube, dropping its pressure and temperature drastically before re-entering the indoor unit to repeat the process. Key advantages of split AC. Zoned and efficient cooling. Unlike large central systems, split units allow you to cool individual rooms independently, saving energy by only running where needed. Quiet operation. Because the loudest components, the compressor and condenser fan, are located outside, the indoor environment remains exceptionally quiet. No major structural changes. Unlike window ACs or ducted systems, split units only require a small hole, around 3 inches, in the wall to pass the refrigerant pipes and electrical cables through. Essential maintenance best practices. To prevent system breakdowns, maintain high cooling efficiency, and maximize your system's lifespan, keep these practices in mind. First, clean filters regularly. Clean or wash the indoor unit's air filters every 2 to 4 weeks during periods of heavy use to avoid restricted airflow and coil icing. Second, clear outdoor debris. Ensure at least 60 to 90 centimeters of open space around the outdoor condenser unit, keeping it free from leaves, dust, and plastic bags. Third, set ideal temperatures. Running your remote thermostat between 24 degrees Celsius and 26 degrees Celsius strikes the best balance between individual comfort and reasonable electricity consumption. Fourth, address issues early. Never ignore strange rattling, clicking, or buzzing sounds, water dripping from the indoor panel, or a sudden drop in cooling performance. Catching small electrical or refrigerant leak issues early prevents costly compressor failures.